In this session, we're going to talk about RDS collections and how it works, scale sets, and when to use a collection versus individual session hosts. This is going to be a real deep dive into RDS collections, which is a key foundational element of building a successful cloud practice in Microsoft Azure. Enjoy the session.
We are going to spend more time talking about RDS collections today. Okay, so just as a summary, we spoke about how RDS collections work. We spoke about the scale sets and the things that they integrate with. Let me just summarize. So remember, a standard environment starts with an RDSH01 session host that can be customized. And then when you create a collection, you select that host or another host that you may have cloned from that host, which becomes the base image for that collection. The base image becomes a VM that can be turned on and modified. And then the members of that collection, also known as scale set instances, can be updated to the version of the image if it gets changed, right? So basically, if you are, let's say, applying software patches or Windows updates, you would power on the template, you would make your changes, you would shut it down. When you do that, it's going to write it back into the image. It will update the scale set, and now the instances of that scale set will become out of date with that base image. They'll still continue running, and then you can click on them to update either the entire collection or individual hosts. So again, what I was talking about is you have this template, which is a VM that has been updated on September 14th. And you can see that the version of these individual instances of this template are the same version as the template, so there's really nothing to update. But if it was a different version, then you would be able to click here and click confirm, and it would update it. Okay, so that is how the pieces all fit together. It looks like we have some activities going on in there. All right, hopefully we'll be able to go through the demo here. All right, so the collection, let's talk about when to use a collection versus individual RDS session hosts. So a simple environment it always starts out with a RDSH01, which is the first session host, and you can assign users to it. You want to add collections for a number of reasons. You want to add them for sort of high availability and redundancy, because collections have multiple members or multiple RDS session hosts that are sitting behind the connection broker. So if one of them goes down, let's say there's some updates that need to be applied or something crashes, you can have the very same users who were on that particular RDS session host get disconnected. Obviously, that machine reboots. And then once they reconnect back, the connection broker will know that there are additional VMs available inside of that collection and place those sessions in those VMs. So it gives you more high availability and redundancy for sort of OS and software level failure. So that's probably the most common and the most compelling reason to use collections. On the flip side of it, there are additional costs and trade-offs that you make by using collections. On the dollar side, there are additional costs involved because you now need a connection broker VM. So if we look at a typical environment before a collection is created, this VM doesn't exist. So this VM has to be created, so that adds a cost into it. You also need to have a template VM, which is usually shut down, but it has a disk that you pay for, and when it's powered on, there's some compute charges. So there's this additional VM. And then you also have this image, which is independent of this VM. This VM is the template, and then the image gets created from this VM when you shut it off, and that has a storage cost as well. So for example, if this VM has a P10 disk, when you modify it and shut it down, it will create an image off of this VM, will also use a P10 disk. So you now have a connection broker, which is a running VM with a disk. You now have a template VM, which is usually a stopped VM with a disk. And then you also have an image, which is not a VM, but is just basically a disk. So you have, you know, if you're using P10s and they're $20 a piece, so that's three additional $20 disks, that's 60, plus the cost of the connection broker, maybe another $100, $200. So it's a non-negligible cost for a small environment, but it's pretty negligible for a sizable environment. So generally what we see is that small, simple environments can get away with a single RDS session host. Is you need to increase its capacity, you scale it up by adding more CPU and RAM into it rather than scaling out, which is what RDS Collections does, right? It always uses the exact same VM and it just creates more of them rather than growing the existing VM. The advantage of doing that is users who are currently connected to the VMs when the scale set grows are not affected. So you're only adding additional capacity and then any future logins will go to that additional server. Whereas if you're using scale up, scale down methodology, you have to actually shut the VM down to resize it to something either smaller or bigger. Okay, the other thing to remember about RDS collections is individual VMs inside of that collection, the session hosts, are basically floating and are sort of non-persistent in a sense. So if you think about the VMware Horizon scenario, it's as if you're logging into a floating automatic desktop that is sort of fresh or could be fresh at any given time, which is a plus and a minus, right? On the plus side, you're always sort of getting a clean environment that's based on a template that you've pre-configured, and any sort of corruption that gets introduced can be easily removed by refreshing that host. On the other hand, you now also have to worry about user state and kind of keeping things, the changes that user make. Anything they would write to the C drive, for example, would not be persistent. So next time they log in, they may be placed on another VM, and on that VM, the changes they've made to the C drive are not there, right? So you have to think about those scenarios as well. Normally, collections are used for larger environments where every user is pretty similar. So the workloads and the applications are consistent across every user. And people are kind of discouraged from writing anything to the C drive because obviously it doesn't persist. In an RDSH environment, when you have a user assigned to a particular host, then those changes are persistent, and unless an administrator goes in and deletes that server or makes changes to it, those changes will be there, so the user state is always persistent. On the other hand, if some corruption happens, you're now dealing with either having to fix that server or maybe to clone one from another template. So there's a lot more remediation efforts that have to go in when you have users assigned to individual session hosts rather than to a collection. Okay. Now, once we realize that each VM inside of an RDS collection is floating and non-persistent, or could be non-persistent, we have to talk about profile management. So with profile management, when we're using RDS session hosts, we use native profiles, meaning that in C users, the user's profile just lives there, with the documents, desktops, and favorite folders being redirected by group policy to FSL1. So if you think about, any content that gets stored on the desktop or in documents will persist if a user gets reassigned to a different session host, or if that session host has to be recreated. But any changes to the user registry, their background, their printer settings, anything that lives outside of those three folders that I mentioned is going to be erased. So when profile corruption happens, we have that feature in the NAP that allows you to restore a previous version of the profile. In a collection scenario, you cannot use native profiles because you imagine you log in today, you configure your Outlook, you log off, you log in tomorrow, you're placed on a different VM, and now your Outlook needs to be configured again, right? And that would be the case for every setting. So in order to be able to utilize these non-persistent session hosts, we have to use a profile management solution that is native to RDS called UPD, User Profile Disks. This works by having a VHD file stored on FSL1, and it gets mounted into the C users folder during logon time. So everything that gets written into the profile gets put inside of that VHD file, and then that VHD file sits on FSL1. So no matter what member of the collection, which VM you're being logged into or a user is being logged into during today's session, that profile disk is going to be the same because it's being stored on FSL1 centrally. The desktop documents and favorites folders are still redirected into a separate location in FSL1. So think about those three folders being redirected as being the consistent setting for both individual session hosts and collections, but the rest of the profile is either native, meaning it sits on a C drive when you're using individual session hosts, or being in a UPD when you're using collections. One outcome of using UPDs is that the OneDrive client doesn't support being used when the profile is not local. So it will detect that you're redirecting the profile and it will refuse to install itself. So when you're using an RDS collection, the OneDrive client cannot be installed inside of the user session. Whereas if you're using an individual session host, because we're using native profiles, the OneDrive client does work. So a couple of other things I wanted to mention regarding management of individual session hosts. So you can see that there are these session hosts inside of a collection. There is a generate RDP button here that will basically know the name of the VM and its IP address, and it will create a file that's supposed to log you into here. But what we've noticed is that if a server is a member of a collection, sometimes it will place you on one of its peers. It's not guaranteed to actually end up on this VM. I think in order to be definitively placed on this VM, you need to use the /admin switch when using the remote desktop client. And when you do that, you will always 100% of the time be placed on the VM that you're trying to connect to. So yeah, so if you need to make changes to an individual host, or you need to log into it and just if there's a particular host that's having a problem and you want to restart it or whatever the case may be, then using /admin guarantees that you're going to be in the right place. And then you can obviously, once you're logged in, you can see what machine you're on by either IP address or machine name to confirm that you're in the right place. Okay, I don't think we talked about the scale out parameters last time, right? So here are a couple of these collections. We looked at the manage host screen. You have the individual hosts here that you can deactivate, and deactivate means that it places it in what's called drain mode. And in drain mode, it doesn't disrupt the current connections, but it does prevent any future connections from happening. So this deactivate is useful if you're planning to take a host offline, but you don't want to disconnect everyone right now. You put it in drain mode, and then maybe you give users till the end of the day, or maybe you send them a message saying, hey, we're going to take the server down in X number of minutes, and then you can take it down. The update host we talked about, this basically brings it up to the version of the template. Send message allows you to send a particular pop-up text to all the users that are currently logged in. Then we have restart, shutdown, and delete. Those are self-explanatory. Restarting, we'll do it at the VM level. So if the VM is hung, it's going to try to do it through the Azure agent first, and then if that times out, then it's going to do a cold reset. Deleting the host will literally destroy it, right? So it will go in and delete this particular instance of this RDS session host. Okay, so we also have an add button. that will allow you to manually add a host to the collection. There's two ways that a host can be added, either by clicking the Add Host button right here, or by triggering one of the Autoscale trigger or the Autoscale trigger for a new host to be added. And we'll look at that next. So this is a manual way, and then there's also a way to let it be automated. On the template side, you can power it on to modify. Once it's powered on, you click on the button that says power off and set as image. And you can also say update host. This will basically update all of the hosts instead of doing it one at a time. Alternatively, if you go back up to the server screen and you see these collections here, you can click on update hosts, and that will do the same thing as that previous button I showed you. You can delete the collection. When you delete it, it's going to delete just the collection, but will leave the connection broker in place, even if there are no other collections left. So that's important to know. If you're like getting rid of collections because the customer tried it and they don't want to use it, you have to delete the collections themselves, and then you're going to have to destroy the connection broker to not have to pay for it. Let's look at Autoscale. So Autoscale is getting modified a bit, but here's how it works right now. So first we have the boundaries. This is the minimum number of members in the collections, and this is the maximum number. And then we have this standby parameter. The standby parameter is the number of hosts that are going to be available but powered off. And the reason we do this is because it's much quicker to power on a VM than create a new one from scratch. And it's much easier to power one off than to destroy one. So what this allows you to do is it allows you to scale out quicker. And then the drawback of having standby hosts is that even though they're not running, so you're not paying for compute, they do have an OS disk, so you are paying for storage even if the VM is not running. So you kind of have to balance having, either no standby hosts if you want to be super efficient with money, right? And you don't want to pay for any storage that's not being used, or having all of your hosts be standby hosts, meaning that they never get deleted and recreated. They only get powered off and powered on. But in that case, you're paying for that storage even when the host is not powered on and is not available to the users. And then the next parameter is the logic. So these are the triggers that will cause the system to either scale out or scale in. So the scale out is pretty easy because it basically says if the aggregate usage across all the hosts is a certain percentage of CPU for X number of minutes, then it triggers a scale out operation, which means a new host gets added. Once that new host is added, then this timer sort of resets, and then it watches the system. And okay, and if it's still above 70% for 10 minutes or more, then it's going to add another one, etc., until that trigger is no longer being tripped. Removing hosts is a little bit more complicated. So there are a couple of things that have to happen in order for a host to be removed. And now again, when I talk about removing or adding, if you have standby hosts, adding means power on and remove means powered off. So it will always act on the standby host first. And then once that standby host is powered on and you have this parameter set to 1, it's going to go ahead and create another standby host and keep that one powered off. Okay, so just keep in mind that the adding and removing doesn't necessarily mean always creating a new host. It could mean power one on or power one off. So now, so a few conditions have to be met. You have to have a certain utilization be below a certain percentage for a certain number of minutes, and it has to be after a certain period of time. And then you also have this parameter, which basically sends a message to the users X number of minutes prior to the host actually being scaled in, that tells them that they need to log out. So what happens, for instance, let's say 6 o'clock rolls around, the collection is at 38% for 20 minutes or more, then users get a message saying your host is going to be, it basically gives you this message that means it's going to scale in. And then 10 minutes later, the system will again check and see, is the utilization still below 40%? And if it is, it's actually going to go ahead and remove that host by either deleting it or by shutting it down if it's a standby. If, on the other hand, we were very close to 40% at 6 p.m. and then 10 minutes later, this utilization maybe jumped from 38% to 41%, then the system will say, oh, wait a second, that was a false alarm. While I was waiting for my 10 minutes here, the utilization actually jumped back up. I'm going to cancel that pending request to remove a host. So for scaling in, there's like a few more things. There's a time cutoff, which is optional. You can say anytime, but usually business hours is a good setting. There is a CPU threshold. There is the duration, and then there's also the message duration, which then gets validated against these parameters after this 10 minutes expires. Okay, a couple of things that we ran into that's important to let partners know and important in troubleshooting any collection-related issues. So pending updates, or just updates in general, we've seen that throughout, MPC and NFA, but a lot of times if you have updates that are not fully applied, when you spin up a VM and it gets, what Azure calls specialized, when it gets added to the domain and it gets its own SID and it sort of becomes a specialized VM, if there are updates that are running or pending, it can really screw up that process. It can cause things to time out, it can peg the CPU and make things fail. So it's really important that before creating a collection, the session host that you use to create the collection from, right? So if we were to click add collection, we would have to select an RDS host template. In our case, we only have this one. So it's really important to log into this machine first, download any updates, apply them, reboot it, wait for it to be done, right? So just have the machine be converted to an image when it's sort of in a quiet state rather than it's in the middle of doing some things, so that every instance that gets added is going to have to do those same things every time it boots up. But basically, the way Azure adds VMs that are Windows is using the basic sysprep functionality that's now part of Windows, that is part of Windows. And sysprep uses automatic login to run itself. So meaning when a sysprep runs on the machine, it reboots the machine and it needs to be able to actually configure the VM to log into Windows with whatever credentials sysprep needs to use in order to complete the process. Anything that prevents sysprep from auto-logging itself in is going to basically cause the process to stall. Sysprep won't complete, the image will never get fully provisioned, and then the NAP scripts will error out and time out. Okay, so we had a partner that was using hybrid AD, and they were adding a collection into their external Active Directory. And in their external Active Directory, they had a disclaimer screen that came up on every login and needed to be acknowledged by clicking OK. And this was, again, this was a group policy in their external domain. So when they added a collection, and that collection was spinning up VMs inside of that external domain, the group policy started applying, right? Because it's now part of that domain. And they were getting a disclaimer screen, so the image could never complete creating itself because sysprep couldn't fully log into the machine. So that's an important thing to keep in mind. Remember, Azure has that diagnostics console view where you can actually see what's on the screen. And if you're noticing that RDS collection creation is erroring out, then looking at that diagnostic screen can be very helpful to see what's going on, what's on the screen that's preventing the process from completing. When you are doing any collection operations, there are some minimum prerequisites of VMs that need to be available. So first of all, I'm not sure why Microsoft implemented it this way, but to do anything with the very first deployment of RDS, you need to have a session host. And because when you're first deploying a collection, you don't yet have a collection, so you need a session host to be kind of used to initialize everything. So RDS H01 must be powered on and available when you are creating the new collection. Okay, so now if you don't have it on, it will give you an error message that's going to tell you that it needs to be on, and things will be pretty graceful. The other two are important. So remember, every command that runs in the domain needs to have the domain controller available. So if the domain controller either is shut down, restarted, or in some other way unavailable during the RDS collection process, then things are not going to complete correctly. And same thing applies with the RD connection broker. Imagine you're adding a new collection, and then somebody goes in and reboots the RD connection broker to apply some updates or something during that process. So that RDS collection procedure that takes half an hour to 60 minutes to run is going to fail. So those are the prerequisites of what needs to be available. This needs to be available for the very first collection creation, and these two need to be available for the entire duration of the operation.